In my last class, I have given the clarity about method synchronization and static synchronization, block synchronization, just a little bit point that I have given the information. So in Deadlock, so I will show you a block synchronization. So today we will know what is deadlock. So this is one of the important terminology in multi-threading context, particularly in synchronization context. So what is deadlock? Suppose one scenario that I am showing. So let we have two threads T1 and T2. Let we have two threads T1 and T2. Similarly, we have two resources. We have two resources. Let R1 and R2. Now, T1 is acquiring R1 means able to access R1 for starting its execution and trying to access R2. Similarly, for completing its execution. Similarly, T2 have acquired R2 and trying to acquire R1 for completing its execution. So if T1 will complete its execution, if T1 is able to access R1 and R2. Similarly, if T2 is able to complete its execution, provided that if T2 is able to access R1 and R2. But here T1 is trying to access R2, that means T1 is trying to synchronize R2, lock R2. Similarly, on the other hand, T2 is trying to synchronize R1. Then particularly in this context, T1 never release R1 to T2. T2 never release R2 to T1. So if no compromise in what will do in between T1 and T2, then T1 and T2 never execute completely. So that, or particularly this scenario, is called as deadlock. Deadlock is a situation. Deadlock is a scenario where no thread executes completely. If compromise will arise, then suppose T1 will release R1 to T2, then T2 will start its execution by taking R1 and R2. After completion, then T2 will release, then T1 will take, then T1 will start its execution and happily it will complete. But here T1 never release R1 to T2. Similarly, T2 is not able to synchronize R1. T1 is not able to synchronize R2. T2 is never quite acquiring or is not able to access R1 or synchronize R1, in which way that you can say. So this is called as deadlock. So this point, so we will write, suppose you think and imagine, suppose in a traffic post, suppose if there is no traffic. So suppose in our Joydev Chowk, suppose there is no traffic. So what will happen particularly on Chowk? From Fatia side, whatever the vehicles are coming. From Rajbhavan side, whatever the vehicles are coming. From Cuttack side, whatever the vehicles are coming. So they will what uh, reach particularly at the traffic junction. So every vehicle they will think, so I will move first, I will go first. So as a result, no vehicle can move because if there is no traffic arrangement in traffic chowk. So that scenario is a deadlock. Similarly, so in our context, if I will say deadlock is a situation where no thread execute completely. So this part I can write, let T1, T2 be two threads and R1, R2 be two resources respectively. T1 have acquired R1 and trying to access R2 for completing its execution. For completing its execution. Similarly, T2 have acquired R2 and trying to access R1 for completing its execution. But here P1 never, or T1 is not able to access R2 and T2 is not able to access R1. So here T1 is not able to access R2 and T2 is not able to access R1. Hence, T1 and T2 never executes completely. This is known as deadlock. So, deadlock is a situation. Deadlock is a situation where no thread execute completely. So I can say deadlock is a situation where no thread execute completely. So in this way that I can write the definition. Now I will go through what an example practically that we will see what is deadlock or how to represent a deadlock. So let my class name is deadlock. Let example. Let here I will change my program name deadlock example.java. Okay, so now we will say. So first of all, as for our explanation, as for our scenario, that I will take the example. So already I have done the figure. You see in the figure. So I will take two resources and I will define two threads. So whatever the points we wrote, so accordingly we will represent T1. First we'll try to synchronize R1 and then we'll try to synchronize R2, then in output scenario that's what we are getting, we will see, and finally we will see it is a deadlock or not. Okay, so now suppose resource, whatever the operating system allocating resources, so that is completely abstract, but one resource that we can consider, that is the object. Then already we have studied which value, which data we are considering as object data, that is string value, because we have known every strings are objects. So that's why I will do string value, let r1 equals to let java, then I will write string r2 equals to let express. So I will say R1 is my one resource, then R2 is my another resource. Now, first what I will do, so first point is I will define a thread. I will represent a thread. Okay, then so we have studied, we have seen how to create a thread, how to represent a thread. So create a class which extends thread class. We have seen create a class which implements runnable interface. That point also we have seen. But here, so another way that we will represent or we will define a thread, you see, so thread is a built-in class that already we have known. T1 equals to new thread. Explicitly, I am defining a thread class object. Thread is a class name. Class name, object name equals to new class name. So now T1 is my thread object, or I can say T1 is my first thread. So this is the one way, and curly bracket begin and curly bracket end, and there is a semicolon, the general form. So this is the one way that we can represent a thread. Now we can say T1 is my thread. So my first objective, what D1 will try to access R1. Suppose my problem statement is letted. Suppose just a little bit point that I will add. Suppose after 1000 millisecond, after 1000 millisecond, suppose T1 will try to synchronize R2. Okay, so we know that to fully define a thread, it is mandatory that we need to define run method, an overridden method, not run method. Public void run method, because run method representing our what? Job. What is the task? Okay, so what I will do, so first we will do what, T1 will try to synchronize R1. So in which way that I will write, you see, synchronized. So I can write R1. So in this way, so I can write system dot out dot println. So I can write in T1 R1 log, suppose. Okay, so you see, so this representing a block synchronization. It is representing block synchronization. So in block synchronization, already I have told, in a deadlock scenario I will show you what is block synchronization. Specific resource, if I want to synchronize, so that representing block synchronization. So here, so T1 is trying to synchronize R1. T1 is trying to synchronize R1. Suppose my point is, my problem statement is, suppose currently I told, suppose one point that I will add, suppose after 1000 millisecond. Okay, so for 1000 millisecond the control will sleep. So already we have known there is a sleep method, but sleep method is a static method. It is directly invoking by thread class. Then another point is sleep method, if I will use, it is a such method, it is throwing what checked exception by default. So when sleep method I will what use, so I will write within a try block and catch block. So I can write thread dot sleep method within a bracket 1000 millisecond. So once I will specify a try block, then I will specify a catch block. Okay, then after that, okay, now P1 will try to synchronize R2. So in this way, I can write system dot out dot println. So I can write in T1, so R2 log. Okay, so T in T1 R2 log. So this is one output statement. So I am trying to display. So another after 1000 millisecond, T1 are two locked. But which output is coming, that we will see. So now this is my T1. So in this T1 representation, this is my thread T1 representation. Okay, so what I am trying to do, I am trying T1 is trying to synchronize R1, and after 1000 millisecond, T1 is trying to synchronize R. It is block synchronization, or basically it is called as block synchronization. Okay, so this part I can write also what, so T1 trying to synchronize R1, and after 1000 millisecond, okay, after 1000 millisecond, T1 trying to access synchronize T2, sorry, R2. So trying to synchronize. Okay, so T1 trying to synchronize R1, after 100 millisecond trying to synchronize R2. So one thing that I will do, so because I have to represent two threads, so now this part I will copy, Control C, I will copy and I will paste here. Simply, so instead of T1 I will write T2. So T2 is first trying to synchronize R2. So here I can write in T2 R2 locked. Then after 1000 millisecond, T2 will try to synchronize R1. So here I will write in T2 R1 locked. So in this way, so T2, another thread I presented. So T2 trying to synchronize R2, then trying after 1000 millisecond, then trying to synchronize R1. Okay, so we will see. So in this way, so T1 thread T1 I presented. In this way, thread T2 I presented. Now, very simple. Okay, so now I will start. So when a thread will start its execution, when start method I will call. When start method I will call. Okay, so now this is my program. So I will see. So now I will hit run. So we will see what the output is coming. Okay, you see output is incomplete. In T1 R1 locked, in T2 R2 locked. So you try to understand what the output is given. So in T1 R1 locked, in T1 R2 locked is not coming to our picture. So that means T1 is not able to synchronize R2. Similarly, in T2 R2 locked, that means in T2 R1 locked, that point is not coming to our picture. That means T2 is not able to synchronize R1 or access R1. So that's why, so it is not ending, it is not a complete output. So here from the output screen we got clarity. So no thread T1 and T2 not execute completely, so not executed. Okay, because T1 only able to access R1, similarly T2 only able to access R2. T1 so is not able to access R2, similarly T2 not able to access R1. So this is called as deadlock. So overall, we got the clarity. Deadlock is a situation. Deadlock is a scenario where no thread executes completely. So I hope you got clarity.